This is video number 10 on the topic motion in a straight line. Timestamps are given in the description box. You can watch parts of video if you're running short of time. In this video, I will discuss equations of motion for a body which is falling under gravity. Earth's gravity is acting downwards, so if we take the upward direction as positive, then the acceleration is minus g, where g is 9.8 meter per second square. The three equations of motion of a body where the acceleration is uniform and constant are v equal to the initial velocity v naught plus a into t, where a is the acceleration, which is a real number, and t is the time. Displacement x, the motion is along the x-axis, so displacement, the x value, is the initial velocity into time plus half a t square. And the velocity square at any time is initial velocity square plus 2ax. The first equation gives how the velocity is changing with time. Second, how the displacement is changing with time. And third, how the velocity is changing with displacement. So we can consider three cases. First one, so there is the Earth's surface. And the body is thrown upwards. Say with the initial velocity u. The Earth's gravity is downwards, which is opposite the motion. So the velocity will keep on decreasing as it moves up. So at some stage, the velocity will become 0. After that, because of the Earth pulling it down, it will turn back and the velocity will keep on increasing. And it hits the ground, the velocity will be of the same value u, but the direction will be opposite. So this is one possibility. Second case, the body is thrown from a height. Upwards with the velocity say u. Since the Earth's gravity is pulling it down, the velocity will keep on decreasing until it becomes 0 at the topmost point, and the velocity will keep on increasing. Until it reaches the same level, the velocity will be u, but in the opposite direction. Here, the velocity will increase further, and the velocity will maximally touches the ground. So in the downward motion, the velocity will keep on increasing because the acceleration is supporting the motion. So here, this is thrown upwards from height. Instead of that, you can also throw downwards from a height. Give an initial velocity u. So as it comes down, the velocity will increase, and if it hits the ground, it will hit with the maximum velocity. So here there is no turning back, just falling down. The third case is from the height it's being dropped or it's just released. So the initial velocity u is 0. So the velocity will keep on picking up and have a maximum value when it reaches the ground. So the ball which is being released with the initial velocity 0 is called free fall, because just dropping it. So with this understanding, you can solve this question. You can read the question. Your ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. E, how high will the ball rise? And B, how long will it take before the ball hits the ground? Take G equal to 10 meter per second square. So there is a multi-story building. So this is the Earth's surface. And the ball is being thrown vertically with the initial velocity u equal to 20 meter per second. And it is the top of the building is 25 meters from the ground. So since Earth's gravity is downwards, the velocity will keep on decreasing until it turns back with the velocity is 0 at the turning point. So first part of the question, you have to find this height h. How high will this ball go from this top of the building? To do that, we can use this equation of motion v square equal to u square plus 2as, and we'll choose this coordinate system. This is the origin of the y-axis, and this is the positive direction. Upward is the direction is positive. So this equation is sublaid between this point and the topmost point. So the topmost point, the velocity is 0, and u at the initial point is 20, and acceleration is downwards minus g. Upward direction is taken as positive, so it's minus 10. And the height between these 2 points is h, which you have to find out. So this will give h equal to this one 20, so 20 meters. So from the point where it's thrown goes to a height of 20 meters before turning back. And what is the time taken for the ball to go from here and finally hit the ground? So this is the final point and this is the initial point. What is the total time taken? This we can find out by considering this motion in 2 parts. For the upward motion, let the time taken from, let me call this point as point A, and the topmost point as point B, and the place where it hits the ground as point C. So time to go from A to B. That we can find using V equal to U plus A, because V is known between these 2 points, between A and B. V is 0, U is known, acceleration is known. From that I can find the time to go from A to B. So this V is 0 at point B, and the initial velocity is 20. The acceleration is minus g, because upward direction is positive, and t is time to go from A to B. So this I am applying between the points A and B. So this will give time to go from A to B as 2 seconds. And then we can consider this motion from B to C. For that, the convenient coordinate system will be, this is the origin of the y-axis and the downward direction is positive. And I can use S equal to ut plus half at square. U is this velocity at this point. Is equal to ut plus half a t square. So this I'll use for this motion B to C. So that gives me the total displacement, which is h is 20, it's 45 meters. The displacement between this point and this point, between B and C. And downward direction is positive. U is 0, because velocity this point is 0, and half acceleration is plus g, because downward direction is positive, and then t is time to go from b to c square. So this is 5. So 9 equal to time square. So time to go to from b to c is 3 seconds. So the total time to go from a to b and then b to c is 2 plus 3, 5 seconds. So total time to go from a to b and then to c is 5 seconds. There's another way to solve this question. We can take this entire motion and take this as the initial point and this is the final point and apply is equal to ut plus half at square between the points a and c. So consider this entire motion from a to c and use this equation of motion is equal to ut plus half at square and we'll take this coordinate system. So for this the displacement of the initial point and the final point is 25 but in the negative direction. So it's minus 25. So you have to carefully with the sign and also the values. And you have to choose the coordinate system which is convenient. So for the motion A to C, the entire motion, I'll choose this coordinate system. Origin is at this point A and upward direction is positive. So displacement between the initial point and the final point is 25 but in the negative direction. So it's minus 25. And then U is upwards 20, so plus 20. And the time is time to go from A to C, the total time. And then plus half at square, half E. E is minus G because upward direction is positive. And then time square, which is the total time square. So 5 can be cancelled throughout. So this will give minus 5 equal to 4 times the total time A to C, and this is minus t square. Because this is 10 by 2, it's 5. 5 will go, so minus 1 will remain. So this is a quadratic equation, which is t square minus 4t minus 5 equal to 0. T is the total time. So this thing minus 5 when split into factors should give me minus 4. So it's multiply should give minus 5. So minus 5 and 1. So the factors are minus 5 and 1. So this can be factorized as t minus 5, where t is the total time, plus 1 equal to 0. We can check t square and then this will be minus 4t and this will be minus 5. So time is 5 seconds. This is the total time go to from A to C, which is same as the one which is got with the other method. So either you can analyze this motion from part by part from A to B and then B to C, or you can take the entire motion and we have to choose the coordinate system properly. For A to B, I choose this origin and this upward direction is positive. To get analyze the motion B to C, this is the convenient coordinate system. Origin is the topmost point, the downward direction is positive. And for the entire motion, again, I'll choose this first coordinate system. 5 is the correct answer. So that's how it's solved here. Upward direction y-axis, upward direction is vertically, up direction is positive, 0 on the ground. So initial velocity is plus 20, acceleration is minus g, and the final velocity at the topmost point is 0. So v square v square. From there I get the height of the building as 20 meters. We can go through this one. And to get the time, so two methods. First method, analyze the motion in two parts. First part is going from the top of the building to the topmost point where the velocity is 0. So from there I get the t1 as 2 seconds. And the second part is equal to ut plus half at square. You get t2 as 3 seconds. So the total time is 2 plus 3, 5 seconds. Second method, analyze the entire motion and then use s equal to ut plus half at square. And here you can also choose the coordinate system like this, the origin of the y-axis on ground and upward direction is positive. So with this thing, the initial displacement, let's say the displacement of the point A, it's plus 25. That is y naught. And the final displacement with respect to this thing is 0. So S is y minus y naught equal to ut plus half a t square. So from there, get the total time. This is a quadratic equation. Phi can be cancelled and then factorized. So t equal to 5 seconds. So to summarize, the motion is like this. The ball is thrown from a height from the top of the building, and this is the Earth's surface. So from here, when it goes up, the velocity will keep on decreasing. So the topmost point, the velocity will be 0, because while going up, the acceleration is pulling it down because of the Earth's gravity. And after that, it will come and hit here. So it's going up, the velocity will keep on decreasing. And it's coming down, the velocity will keep on increasing. Because for the upward motion, the acceleration is opposing the motion. For the downward motion, the acceleration is supporting the motion. Ask your doubts in the comment section.